Namaskar. Good afternoon and greeting to everyone. This is a day two of our program for orientation of science teachers, that is post, organized by Shiksha Shilpi. So आज का ये हमारा दूसरा दिन है and in the second day I welcome you all. मैं सभी को इस दूसरे दिन में आप सभी का स्वागत करता हूं। आज का ये पूरा जो सेशन है, ये पूरा सेशन हमारे जो कोर कमेटी के मेंबर हैं मनोज जी सवाईकर, जो गोवा प्रांत में असिस्टेंट डायरेक्टर के रूप में कार्यरत है, वो आज के इस सेशन में पूरा मॉडरेशन करने वाले हैं। इस आज के दिन में मैं आपसे थोड़ा जानकारी साझा करना चाहता हूं। The first and foremost thing is that you have to register for this dashboard. The credential of the dashboard are given to you all through SMS. And if anyone doesn't get it, please just, I already told to you in the last session also, email to our admin at vvm.org.in. सो आप उसको एडमिन में अगर किसी को नहीं मिला है क्रेडेंशियल, तो आप सीधा ईमेल द्वारा हमें जानकारी दे सकते हैं। तो हम उसके इंफॉर्मेशन, whatever the information we received from you, accordingly we will send you the credential. This is one thing. And I also have to inform that we have some of the people, जैसे हमारे हेमंत जी पांडे है, जैसे हमारे शुभदा शिरोडकर मैडम गोवा से है, और कई सारे टीचर्स हैं जो इस टेलीग्राम ग्रुप में बहुत ही सक्रियता से काम कर रहे हैं और जो टीचर्स की क्वेरी है उनको रिजॉल्व कर रहे हैं। तो ऐसे सारे टीचर्स जो एक्टिवली सपोर्ट कर रहे हैं, एक्टिवली पार्टिसिपेट कर रहे हैं, उनका भी मैं सभी शिक्षा शिल्पी की ओर से स्वागत और अभिनंदन करता हूं। तो आज के इस प्रोग्राम के लिए हमारे यहाँ जो उपस्थित एक्सपर्ट है, वो उनके द्वारा जो आज ये प्रोग्राम साझा होने जा रहा है, उनके प्रति मैं अभिवादन करता हूं और मनोज जी से ये रिक्वेस्ट करता हूं कि मनोज जी आप ये आज के दिन का पूरा सेशन के लिए मॉडरेट कीजिए और सभी को अवगत कीजिए कि आज क्या होने वाला है। नमस्कार। मनोज।
आज के सम्माननीय अतिथि, स्टूडियो में उपस्थित सम्माननीय अतिथि, शिक्षा शिल्पी के हमारे संयोजक माननीय डॉक्टर अजय महाजन जी, यहाँ वर्चुअल प्लेटफॉर्म पे उपस्थित सारे शिक्षकगण, कार्यकर्ता, बंधु भगिनी, पिछले 5 सितंबर से हम हर शनिवार और इतवार को एक साथ मिलते हैं। हमारे यहाँ कोई अलग अलग विषय के एक्सपर्ट्स यहाँ आते हैं और एक श्रृंखला जो हमने बनाई है शिक्षा शिल्पी के माध्यम से, तो उसी शिक्षा शिल्पी के श्रृंखला में और आज के जो सम्माननीय अतिथि है, रिसोर्स पर्सन है, उनका परिचय मैं आपके सामने प्रस्तुत करता हूं। If you only learn the methods, you will get stuck at some point. But if you learn the concept, you can develop your own methods. ये जिसने कहा है वो सम्माननीय लेखक, जिसने एक वैदिक मैथमेटिक्स इनसाइड आउट इस तरह का जो पुस्तक हमारे यहाँ प्रस्तुत किया है, वो है श्री चंद्रहास हलाल. He's an engineering consultant with interest with many diverse fields like mathematics and mechanical engineering. Since last 20 years, he has been involved in engineering consultancies, and for last 13 years, he's involved in software consultancies, developing different modules for training. Apart from this, Sri Chandrahas has been teaching different science, engineering, and mathematics subjects as visiting faculty in institutions including BARC, TIFR. He's involved in efforts to popularize science and mathematics at schools and colleges. His book, Vedic Mathematics Inside Out, has been in the top 10 bestsellers list in crossword. He has launched a number of YouTube videos to popularize science. Recent video on Pingala's ancient mathematics, which explores number of facts in Indian mathematics. Moreover, he has developed number of such uh, popular videos on YouTube, uh, which links you can download. We'll try to pass on these links. So certainly you will enrich in this session by Sri Chandrahas Halai on Vedic mathematics. So without taking much of the time, I would like I'm it's my great pleasure to invite Sri Chandrahas Ji Halai Halal.
मनोज जी
Yeah.
चंद्रहाजींना माईक हे सॉरी व्हिडिओ
Good
ऑन
evening.
करायला.
हाँ.
हलाई सर प्लीज
I'm not
start
able
your
to
video.
switch it on. I will have to log out and again log in.
Yes, sir.
That seems to be some problem. I'll log out and again log in. Yeah.
ओके 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 ठीक है येतील ते.
माननीय चंद्रहास के बारे में आपको बहुत सारे वीडियोस स्पेशली ऑन वैदिक मैथमेटिक्स, इंडियन साइंस और उनका बहुत बड़ा रिसर्च अवेलेबल है जो उन्होंने केवल देश में, हमारे देश में ही नहीं लेकिन जग भर में बहुत सारे जगह पे उन्होंने इस तरह के लेक्चर्स प्रस्तुत किए हैं. बहुत इंडियन मैथमेटिक्स एंड इंडियन साइंस के बारे में बहुत बड़ा अभ्यास उनका है. तो आज एक बहुत बड़ी अपॉर्चुनिटी हमारे पास है कि मैं सबको रिक्वेस्ट करता हूं कि आपके प्रश्न भी आप सेशन में प्रस्तुत करें, जो मैं कुछ अच्छे प्रश्न उनके पास रखने की कोशिश करूंगा. चंद्रहास जी.
Yeah. So namaste and good evening, everyone. I would like to first of all thank Vigyan Bharati and the platform Shiksha Shilpi to give me a chance to talk to every one of you. So today the topic is Vedic mathematics, and generally a lot of people who speak about it and write about it, they actually convey a big misconception about it. So generally, when you ask someone what is Vedic mathematics, and then they will tell you it is from the Ved. Another thing, it is gives you a lot of magic tricks to do quick calculations. Well, these are two wrong notions. So in this session, I would like to, okay, yeah, you can do quick mental calculations. That's an added advantage. But Vedic mathematics per se is not like becoming human calculators. Yeah, you become human calculators, but that is not the main aim or the goal of Vedic mathematics. And another thing that people say that it is from the Ved, also that is also a wrong notion. It is not from the Ved. So first, what we call Vedic mathematics. So let me first tell you about Vedic mathematics, and then we will learn about some important concepts in Vedic mathematics. So first, I will start by giving you a brief introduction about Vedic mathematics and the person who created it. So the modern concept of Vedic mathematics is from the book Vedic Mathematics, written by Sankaracharya of Govardhan Mutt Puri. And the name of Sankaracharya is Bharti Krishna Tirthaji Maharaj. I will share the screen so that I can show you a presentation. Yeah. Yeah, everyone can, I hope everyone is able to see the screen now.
No, sir. No.
Yeah, just a
Sir,
second.
हाँ,
Yeah, can you see the screen?
नहीं सर. हाँ, अभी आ
Okay.
गई.
Yeah.
Yes.
It takes a bit of a time for yeah.
हाँ सर. Yes.
So this is the late His Holiness Sankaracharya of Govardhan Mutt Puri, Bharti Krishna Tirthaji Maharaj. He expired in the year 1960. So the popular thing that we know about Vedic mathematics is from the book Vedic Mathematics by Sankaracharya, and the Vedic mathematics that we are going to talk about is from his book Vedic Mathematics. So Sankaracharya was a master in Sanskrit, in history, in mathematics. So he had studied Indian mathematics extensively, had done deep study of Indian mathematics, done research on Indian mathematics, and he had organized mathematics around core concepts. Like if we look at the school mathematics, college mathematics, so we see a list of formulas, list of rules, list of proof, and list of exercises. And students and teachers get a notion that this is mathematics. Whereas Sankaracharya had organized mathematics around core concepts. So we'll be learning one of the concepts today in the short time that we have. We'll be learning one of the core concept. So he was Sankaracharya of Govardhan Mutt Puri and Dwarka. Yeah, this is the cover page of my book, Vedic Mathematics Inside Out. So rather than going on talking about Vedic mathematics and all that, I'll in brief tell you that Vedic mathematics consists of 16 sutra, or the word formulas. Just a second. So these are the 16 sutra, or the word formulae, or 16 concepts. Uh, in Sanskrit literature or Sanskrit works, like even Panini's Astadhyayi, the epitome of a work in Sanskrit grammar, is based on sutra. Now, what is sutra? Sutra are nothing but, you can say, a recipe to do a certain task, or a cryptic codes to describe a theorem. So Vedic mathematics is based on the 16 sutra and 13 up sutra, or sub sutra, or corollaries. So we will look at one of the sutras, that is the first sutra, sorry, the second one, Nikhilam Sutra. Yeah. So now this program is basically for school and college teachers. So I will try and give maximum material for pedagogy and how to convey these ideas to the students. Now, school and college students are much interested in stories, and who doesn't like stories? Even adults want to go for stories. So, Manojji, I hope my video and audio is clear. Hello.
Yes, sir. Clear.
Hello.
Your audio
Fine.
is clear. Yeah.
Okay, and this my screen is visible now. Hello.
Ah, yes, sir. Yes, sir.
Fine. Okay,
Your
then
screen is visible.
okay, then I will start the main session now. So uh, I'll start my session with a story. So now let me start with a story of a farmer. That a farmer had a huge farm outside of the village. So during the day, he used to work on this huge farm, and then in the evenings he used to go to his house. But and when he used to return back to the farm the next day, he used to find that someone had plucked the fruits, someone has stolen the vegetables, and it was making a huge uh, losses because of the theft, regular theft. So he decides, why don't I make a small room? Why don't I construct a small cottage or a small room on my field itself? So he constructs a small room in his farm and started staying there. Let us say the dimensions of the room are, say, x by x meters. Let us say the dimensions of the room are x by x meters. So the area will be x square. And if we say that x is equals to 10, then the area will be 100 square meters. Okay. So now he started staying on the farm itself. And because of that, the number of theft came down and he started earning money. So after some years, he gets married. So when he gets married, he needs an extra space in his home for the living quarters. So adds a room to his, he adds an adjoining room to his living room. And let us say the dimensions are a times x. So width of this room is, let us say, a. So this becomes ax. And we know that x into x plus a is x square plus ax. So the total area of his home is x square plus ax square units. Now let us say if a is 3, then the area will be 100 plus 30, that is 130. Okay. Now I'll just crop this thing. Sorry. Okay. So after some years, kids are born. So he needs to add a room for the kids. Let us say this is B. The kids grow up. Okay. So the area of this room will be Bx. So kids grow up. They go to school. They need a study room. So a study room is added. Let us say its dimensions are AB. So now the dimensions of the house that the farmer has built will be x plus a times x plus b, and that will be x square plus ax plus bx plus ab. Let us say b is 2. So our total area will be, we'll come to that. Let me come to this. So this can be rewritten as and if we say that x is 10, A is 3 and B is 2. So we have 10 plus 3 times 10 plus 2, and that is 10 times 10 plus 3 plus 2 plus 6. So that comes to, wait a minute, I'll clear this again. So it will be, sorry, 10 times 15, that is 10 plus 3 plus 2, or number of tens plus the number of units, and what we have is 13 times 12, that is equals to, so I have a 150 plus 6 or 156. So we can use this algebraic identity, or we have a algebraic identity in a variable x, and if we take that x to be 10, 100 or any power of 10, we can use it for quick mental calculations, or we can use it for quick numeric computing. So I will just start a new screen. Now I can use this algebraic identity for quick mental calculations if I replace x with any power of 10. So I can say so suppose if I have 13 multiplied by 12, so I can write it as, say our base is 10. So 13 is, how far is 13 from 10? I'll say plus 3. How far is 12 from 10? Plus 2. So now we have to add this 10 plus 3 plus 2, or I can say 10 plus a plus b, that is also 15. Or I can say 10 plus b plus a, that is also 15. So I get a 150. 10 times 15 is 150. Now vertically multiply, so I get a 6. So 12 times 3, or sorry, 13 times 12 is 156. Let me demonstrate this method by showing you one more example. I'll say 14 times 12. So that is plus 4 plus 2. So I will cross add. 14 plus 2 is 16. Now my 12 plus 4 is 16. My base is 10. I use that base 10. So 10 plus 4 plus 2 is 16. So left part of my answer is 16. And I can do the vertical multiplication. That is 4 times 2 is 8. So 14 times 12 is 168. Let me show you one more example. You can say 15 times 11. So this is plus 5 plus 1. Cross add. So you get a 16. Multiply vertically, you get a 5. So answer is 165. I'll give you 2 minutes. You can make a quick note of this so that we can go ahead. I'll say 14 times 13. So the complement of 14 is plus 4 plus 3. So this is 17. When I cross add 14 plus 3, I get 17. 13 plus 4 is again 17. Now 4 times 3 gives me 12. Now here I have space only for the units because our base is 10. Because our base is 10 and that is 10 raised to 1. We have the space on the right side only for the units. So 4 times 3 is 12. So 2 carry forward 1. So that carry forward is added to the left part. So we get 182. Our answer is 182. So if I say 15 times 12, this is plus 5 plus 2. Cross add gives me 17 on the left part. 5 times 2 is 10, 0. Carry forward 1, so I get a 180. Yeah. Okay, we'll go to the next stage now, that we will use 100 as the base rather than 10. Let us say 104 times 103. So now our base is 100. So we say that the complement that we are writing is 04 and 03, because our right part of the answer will contain both units as well as tens, or it has the place for 2 decimal digits. So 100 plus 4 plus 3 is 107, or you cross add, again you get 107. So that will be the left part of the answer. And when we multiply vertically, our answer is 12. Now since the base is 100, we have space for 2 digits. So we have 2 digits here. Okay. Let us say 107 square. Sorry. 107 square. So it is even easier. You add 7, whatever is in excess, you add to the number. So you get 114, and then square the excess, that is 49. Or you can also write it as 07 here plus 07 here, and you get 149. Okay. Let me go on to the next level. So let us say we have got 135 times 102. So plus 35 plus 02. I cross add, so I get a 137 here. And 35 times 2 is 70. Okay. Now I'll take it to the next stage. 135 times 103. And my base is 100. So I space 2 digits only on the right side. 138. Now 35 times 3, and I vertically multiply it, I get a 105. So there is space only for 2 digits. That 1 will be a carry forward. You add it to the next column or to the left part, you get 139 and 05. So this is how multiplication is done using the Nikhilam Sutra. And what is Nikhilam Sutra? All from 9 lasts from 10. Now this is a cryptic code. We will understand when we go to the next stage. Now Nikilam Sutra is used only when you are multiplying two numbers which are nearer to a base of 10. So we are multiplying two numbers which are nearer to any base of 10, any particular base of 10. So I'll go to the next stage. So now to understand the next stage or the next concept, we will again use a story. Now let us say a farmer has a huge farm. Kindly excuse my drawing skills. Let us say he has a huge farm. Having dimensions, say x by x meters. So the area as we know is x square meters or x square yards. Acha. Now you can say x is 10. We'll come to that. Now after some years, now this farm is adjacent to a highway. It is adjoining a state highway. And now the government wants to widen this highway. So what they do, they take away the land. So that land is taken away in land stripping. So this portion is stripped away. And of course, the farmer will be compensated for the loss of his land. He will be given money as a compensation. So this is, let us say, A. The width is A. So now the dimensions of his farm are x times x minus A. So now the area will be x square minus ax. This will be the area. So x is stripped away. Okay. So now he is making use of the remaining area for his and all. Now again, after some years, the railway ministry is active and they want to lay a railway line. So again, they take away a strip of his land. So let us say the dimensions here are B, and I will. So this strip will be taken away. So now his dimensions will be what? A minus x, x minus A into x minus B. Now this shaded portion is kind of B into x minus A. Because now this area, this length, this is x minus A, because A is removed from x. Anyways, so now if you look at from x square, this ax is removed, this bx is removed, and this portion is removed twice. That is, AB is removed twice. So we get x square minus ax minus bx and this portion AB is removed twice. So I will add it once. So that is x times x minus A minus B plus AB. I can use this for quick mental calculations. Let us look at it. So we have so if I say that x is equals to 10 or any power of 10, or then the equation becomes so now we can use this. We can use this relation for quick mental calculations. So this part gives us the left part of the answer, and this part gives us the right part of the answer. So here we are actually calculating number of tens or number of hundreds or number of thousands, and here you are doing the vertical multiplication. So let us apply this newfound knowledge to quick mental calculations. So let us say I want to multiply, say 9 with 8, and we know that it is 72. Now I will introduce you to a concept, complementary numbers. So let us say 8 and 2 are complementary numbers because they add up to 10. Then 7 and 3, they are complements of each other, or rather tens complement. 5 is complement of 5 because they add up to 10. Now 65 and 35 are hundreds complement because they add up to 100. Same way, say 80 and 20, 75 and 25, or you can say 655 plus 345 because they add up to 1000. Or in short, they are all known as tens complement numbers or tens complement. पूरक, एक दूसरे का पूरक है वो. I'll just remove this. So the complement of 9 is 1, that is minus 1. Complement of 8 is minus 2. Or we say that 10 minus 1 times 10 minus 2. And our base is 10. So we are going to 10 minus A minus B. So that gives me 7. Or cross subtract 9 minus 2 or 8 minus 1. That gives us 7. Now minus 1 times minus 2 is 2. So we get that answer 72. Now let us multiply 8 with 7. 8 is complement is minus 2, minus 3. So we get a 6 here and a 5 here. So let us now go to the next level. We'll say 97 times 98. So this will be minus 0.3 because our base is 100. So now we'll be counting hundreds. Minus 2. So cross subtract and you get a 95 here. So, and vertically multiply. So you get a 0.6. So now the base is 100. So there is a place for 2 digits on the right. Okay. 96 times 92 minus 0.4 minus 0.8. So you get a 88 on the left side and a 32 on the right side. So I have a minus 0.3 here and a minus 35 here. So when I cross subtract, I get the left part, and that is 62. On the right side, I get 105, but there is space only for 2 digits. So it will be 05, carry forward 1. So it becomes 6305. Let us say I got this 95 and the 75. You get a 70 here, and minus 25 times minus 5 is 125. So 1 is a carry forward. You get 7125. Now we'll go for the next stage. Now this is my mobile phone number, and I've got 10 nines here. So I need to have the complement here. Here I know I need to have 9 zeros. And a 1. 9 zeros and a 1. But how do I get the complement of my 10-digit mobile number? So Swamiji gives us the sutra Nikhilam Nautas Sharmam Dasatah, or all from 9, last from 10. And what is that? That is a sutra or a recipe or a word formula to quickly calculate the complementary numbers of huge numbers. So how do I get that complement? Subtract all the digits from 9 and this last digit from 10. So 9 minus 9 is 0. 9 minus 8 is 1. 9 minus 2 is 7. 9 minus 1 is 8. 9 minus 3 is 6. 9 minus 6 is 3. 9 minus 4 is 5. 9 minus 1 is 8. 9 minus 0 is 9, and 10 minus 7. 10 minus 7 is 3. So I get a very huge number, and that is 982136410 cross subtract 106, and on the right side I multiply this with -1, so I get a positive number 01786358993. So the sutra, the word formula is all from 9 last from 10. Okay. I think so the time is up, so I will give you only one more example of how to calculate complements quickly using this sutra. So let us say I have this 27899,023. So how do I calculate the complement of this number? So all from 9. 9 minus 2 is 7. 9 minus 7 is 2. 9 minus 8 is 1. 9 minus 9 is 0. 9 minus 9 is 0. 9 minus 0 is 9. 9 minus 2 is 7. Last from 10. 10 minus 3 is 7. So that is how you use. So the word cryptic code or the sutra is given to calculate the complements quickly. So the first sutra in Vedic mathematics is actually the principle of complementary numbers or principle of complements. So I will end my talk here, and we can go for the next stage, that is a question and answer and discussion.
Yes, sir. So I would request all the participants to please put up your questions on your YouTube link
Just give me a second.
on live
Just
chat.
give me a second. Yeah. Yes, sir.
Yeah, till now we have not received any questions.
Okay.
I suppose they are calculating the problem which has been assigned to them.
Given to them. Okay, good.
Yeah,
Good.
yeah.
Manojji, if there are not a single question, you can ask, sir. Halai, sir.
Yes, sir.
You may please continue and discuss the thing if the
For
questions
another
are not in the chat box.
Okay, then that gives me a chance, if I have got 5 minutes more,
Yeah,
to
yeah.
teach them one more concept. One more
Yeah,
small
yeah,
concept I will teach. Okay.
Yes,
Yes, sir.
definitely.
If there
Please
are
go ahead.
questions, then we will stop, or else I will teach them one more concept.
Please carry
okay.
on, sir.
Yeah, fine.
Sir, as and when the question will receive from the chat box, we
Yeah,
will
yeah.
share it to you, and
I'll continue for 5 minutes, and then I will take up the questions or any discussions thereafter. Now,
sir, please.
till now we were taking that x plus a into x plus b, or x minus a and x minus b. What if we have this x plus a and x minus b? So that will be x plus, sorry. So that will be actually give us x times x plus a minus b minus ab. So if x is replaced with 10, we are actually counting 10 plus a minus b. So that is for the left part of the answer, we can either cross add or cross subtract. And then on the left side, we get a minus ab that will have to be subtracted from the left part. So I'll just solve an example here. Say 12 times 9, and we know that it is 108. So complement of 12 is plus 2. 9 is minus 1. So we can either cross add or cross subtract. So the left part we get is 11. Actually, that 11 is number of tens. So it is 110 minus 2. Right part of the answer is minus 2. So it is 110 minus 2. So I get a 1. 10 minus 2 is 0, 8. I will solve some more problems. Let us say we have 104 times 97. So plus 0, 4 and minus 0, 3. So cross subtract or cross add, you get a 101 minus a 12. So 100 minus 12, 10,000, and this is 100 minus 12. So that gives you 10,088. So I'll end the session here. Any questions? Yes, Manoj ji, Manoj sir. Any questions?
Yes, sir. Yes, sir.
Yeah.
Should I place it? The first one
Yeah,
is how can we multiply 3-digit with 2-digit numbers? That is
for that, we have the general rule, that is vertically and crosswise, or urdhva tiryabhyam. So this particular sutra I took because that is the easiest way of doing multiplication. So if you have, let us say, 4-digit number with 3-digit number or 5-digit number with 2-digit number, then you don't go for this special case. For that, you have the general rule, vertically and crosswise, or what Sankaracharya had said in Sanskrit, urdhva tiryabhyam. So in this short time, I can only present some small and simple facts. This is a vast thing. It requires a lot of research and a lot of study.
Yes. So I will just convey it again that few more sutras will be certainly discussed in days to come. If we could request Chandra's ji, then it will be. But then certainly I would inform to all our participants that few more sessions will be certainly conducted on this. So with this, in fact, this is just as Chandra sir has mentioned that it is just a glance into it. But in Shiksha Shilpi, as what we have right in the beginning, as it was informed to you, that we need not create a entire lessons, develop entire lessons in the form of modules here in this, but then it will create a kind of interest. So हम कैसे सीखना है यही हम बताने के लिए ये हमारा प्लेटफॉर्म है. तो एज अ टीचर जैसे चंद्राज सर बार बार बोल रहे थे कि हमें इंडिपेंडेंटली अपनी मेथड्स डेवलप करने हैं, सिर्फ कंसेप्ट डेवलप करके. तो जैसे मैंने शुरू में ही कहा था सर का ये जो स्टेटमेंट है, इफ यू ओनली लर्न द मेथड यू विल गेट स्टक एट सम पॉइंट, बट इफ यू लर्न द कंसेप्ट you can develop your own methods. So that is what is the whole intention or idea behind this kind of sessions. So I am very much obliged to, on behalf of you, I would like to thank Chandra sir. So as he
My pleasure.
rightly introduced the concept
Yeah,
of
sir,
Vedic mathematics. Few
Manojji, Manojji,
basics. Yes. Ah.
Manojji, there is one question for sir, Chandra sir.
Yes, sir.
Uh, Nikhilam Sutra is applicable to only numbers nearer to
Hmm.
base 200.
Pardon?
Sir, he says
Nikhilam
that
Sutra, Nikhilam Sutra is applicable to only numbers nearer to base 200.
Nearer
If
to,
we
yeah, which
want
are nearer
to,
to, uh-huh. Yes, sir.
200, okay. For example, if we want to 87 by, 87 multiplied by 75, we can't
Uh,
use this method.
yeah,
What
for
is
that,
your
as
opinion?
I have, yeah, that was asked in the first question itself. Suppose if I got, say, 27 with 72, then how do I do that multiplication? For that, you use the vertically and crosswise or the Urdhva Tiryakbhyam Sutra. This is a special case which is used to multiply two numbers which are nearer to any like like any multiple of powers of 10, or you can say you can use this sutra to multiply numbers which are nearer to that powers of 10 or any base of 10 or even
Correct.
multiples of powers of 10.
Correct,
So
sir.
for
Correct.
general method, you have the vertically and crosswise method. So I will just
Yes.
demonstrate, since the question is asked. We have, I think so, a couple of
7 minutes
minutes.
more.
So,
7 more,
yeah,
please.
we have couple of minutes. So let me demonstrate that. And yeah, so let's say I got say 43 with 21. So 3 times 1 is 3. 41 is like, then I will do this cross multiplication. 4 plus 6 is 10. So 0, carry forward 1. 4 times 2 is 8 plus 1, 9. So 43 times 21 is 903. I'll show you one more example. Say 33 and 22. So how do I multiply this? Okay, use me 6 when I do that vertical multiplication, and crosswise. So 3 times 2 is 6 plus 6, 12. So okay, then again vertically, 3 times 2 is 6 plus 1, 7. So 726. So we have this general method. And if you look at, I'll show you something interesting. Something very pretty interesting I'll show you. If you look at the cover page of my book, so I'm using this method of intersecting lines to calculate 1111 square. 1111 square, and that is 1 2 3 4 3 2 1. So let me tell you something about Indian mathematics, something interesting that will actually amuse the students and inspire them to learn more about maths and computing. We know that 1 square is 1, 11 square is 121.
121.
Then 111 square is 123 21. Then 1111 square that I was shown is 1234 321, and these are palindrome numbers. These are palindrome numbers. 11,111 square is 1234 5 4321, and 1,11,111 square is 1234 5 6 5 4 3 2 1. And this is a palindrome number. Whether you read it from left to right or right to left, they are the same. And another thing, you know, this number 1,11,111 square was first calculated by Mahaviracharya, a Jain monk who wrote a book on mathematics known as Ganit Sar Sangraha. So this was calculated almost 1200 years back. This was calculated 1200 years back by a Jain monk, Mahaviracharya, who had written the book Ganit Sar Sangraha. And at that time, 1200 years back, the rest of the world didn't have place value number system. The rest of the world didn't knew how to count. So they could not calculate such a huge number. It was only Indians who could do it. So you should use Indian mathematics to amuse the students, catch hold of their interest, and spur their interest in the subject. Yeah, so I'll end the session here.
Yes,
Yes,
thank
thank
you
you,
very
sir.
much.
Thank you.
Any more questions?
No,
I
sir, it
think,
is almost time.
oh.
Yeah.
Okay.
So just I would like to remind to all the participants that our Chandrahasji's book Vedic Mathematics Inside Out has been is available online, and it is one of the it is in top 10 bestsellers list. So that we can, so the main intention behind the whole thing is just to create the interest about mathematics, Vedic mathematics. So I would request all the teachers to learn Vedic mathematics. It is also available online. There are a number of books available in the market. But let us pass on these our ancient mathematical skills which are already there into our children. That is the whole request, and that was the intention behind uh, this session. So with this, I would like to thank Chandrahasji, though we have informed him at the last hour, 11th hour. Uh, in fact, being teachers, we all can understand the difficulties which arrives when anything is being told to us at the last hour. But then still, without having, when he realized that the session is for teachers across the country, and now to sir, to tell you that 172 teachers from across the country have
236, sir. 236.
236 teachers from across the country are participating in this session, and certainly this will enlighten all these teachers to develop that instinct in learning Vedic mathematics. So I take the pleasure to thank you for enlightening us in this session, and certainly we look forward to get associated with you in learning a few more concepts in Vedic mathematics. So thank you, sir, very much.
Thank you.
Thank you.
Shall I
Now the
leave
next
the
speaker.
I can log off now, no? Okay, thank you.
Yes,
It
sir.
is up to you, sir. It is up to you. Okay. Call the another speaker.
Yes, sir. So we have completed our first session, and we are to begin with our second session. And I am delighted to invite Dr. M.R. Ramesh Kumar. He is a retired chief scientist and head of physical oceanography department, National Institute of Oceanography, Goa. He has visited Antarctica more than once. United Kingdom, Germany, Japan, Mauritius, Italy,
नाहीत का ते
Egypt, China, Greece on different assignments such as UNDP fellow. He
तुझ्या
has
ह्याची
participated in several oceanographic
राजला
cruises
फोन करून
on
सांग ना
board
पटकन ऍड कर म्हणा त्यांना
research vessels Gaveshini and Sagar Kanya in different parts of the
कसं
Arabian Sea, Bay of Bengal,
कसं
and
करता येते
South
मला
Indian
करता येते
Ocean.
का इथून काही
He has recently participated in the national program called Arabian Sea Monsoon Experiment, ARMEX. His most important achievement in research cruises has been the participation as a member of the 6th Indian scientific expedition to Antarctica in 1986-87. He has conducted several sessions for MSc Meteorology and Oceanography students of Cochin University, Marine Science students of Goa University, Marine Meteorology and Remote Sensing. He has taken sessions for B students in digital image processing. He has given lectures in National Natural Remote Management System training conducted by NIO. I would place few important awards he has received. He was awarded Dr. N.K. Panikar Memorial Award for obtaining first rank in MSc Meteorology from Cochin University of Science and Technology in the year 1981. He was awarded Professor P.R. Pisharoti Memorial Award for the year 2003 for work in the field of remote sensing, known as National Remote Sensing Award. Fellow of the Indian Geophysical Union. His research interests have been in the area of air-sea interaction, monsoon, cyclones, climate change, Antarctic oceanography. He has more than 80 research publications in national and international journals of Science Citation Index, guided several students for their BTech, MSc and MTech dissertations and PhD from various colleges as well as universities. He has given more than 70 invited talks in various national and international seminars, conferences, and workshops. And apart from this, the most important for all of us is he has been the part of Goa Vigyan Bharati and involved in number of activities being conducted in Goa in under our Vigyan Bharati banner. So I take this pleasure to invite and guide on monsoon and role of climate change. Uh, I welcome Dr. Ramesh Kumar.
Okay. First of all, let me thank Vigyan Bharati and Vigyan Parishad Goa and Ajay Mahajanji and Manoj Savekar. Manoj Savekar has given me a big biodata of mine. So, first of all, I would like to share my screen. I hope the screen is shown here or is screen seen? Hello?
No, sir. No, sir. No, sir.
I think we should ask that the person who is doing should share the screen. Can it be seen now? Because the earlier screen should have been.
No, sir. Not yet. We'll just check. We'll just check, sir.
Okay.
You have to share the screen, sir.
Yeah, I have done it.
Share screen, you have done?
Yeah, I have done.
Then entire screen is there.
Yeah,
there is a one option.
Yeah. I'll do that. Use, okay, share screen.
Use share entire screen.
Okay. I have done that. Okay. I've done that. Is it seen now?
No, sir. There is some problem with screen sharing.
I'll do it again. Is it okay now?
Yes. No. Just try it again, sir.
I'll do that.
Go to share screen. Go to share screen and share entire screen.
I'll do that again. Share entire screen. Okay. Allow. Now it is seen?
No, sir.
One more time.
Sir, the same thing that you have repeated, no?
Sir, need to share the screen. मीन्स आपको क्या करना पड़ेगा, आपको जो शेयर स्क्रीन का ऑप्शन दिख रहा है ना, वो उस पर क्लिक करना पड़ेगा.
I have done that. See, I have done that entire screen. I have done allow also.
पहले हमने okay.
देखो.
हाँ सर, आ गया सर.
Okay.
Yes, sir.
So
yeah,
let me start straight away. On my topic is actually okay. to make the things a little easier, I thought
Sir,
people are
sir, sound is not clear. Your sound is not clear.
okay. Let me just see how I can. I think I have shared my.
Yes, now it is clear, sir. Now it is clear.
Okay.
Yeah, just speak, sir. Just speak, sir.
Okay. Okay. Now let me just go back to the. Okay.
Again, it is.
No. Okay. Is it okay? Hello.
No, there is a break in sound. Is there a network problem, sir? Yeah, please speak.
Unmute, sir. Unmute yourself. Ramesh Kumar, sir, your mic is muted. And please
Sir,
unmute it.
sir, your mic is muted. Please unmute it.
Yeah.
Right.
Okay. Now I unmuted it.
Yeah.
I hope it is loud and clear now.
Yes, sir. Yes,
Yeah. Please continue.
Okay. See, basically, yeah. Now is it clear?
Yes.
Yes.
Hello.
Yes, sir.
Okay.
Yes. It
So
is
let
clear.
me start. Okay, there are two important meteorological phenomena as far as Indian subcontinent is concerned. One is the monsoons, other is cyclones. So I thought I'll talk on both of them, and I'll talk a little bit about climate change also, because climate change is a current, let us say, the flavor of the current generation or the current topic. Or every day you look at actually newspaper, you'll see people mention about climate change, what will happen in future, what has happened in the past. Do we really need to know? But let me tell, starting with the monsoons. In fact, people in India had actually known monsoons from ages or maybe centuries back. If all of you are actually into the reading habit, you might have heard about Kalidasa, one of the greatest poets of India. He has actually mentioned about Megha Sandesha. Megha Sandesha is actually nothing but messenger of clouds. So Kalidasa, even during those periods when the meteorology department or the India meteorological department didn't start or whatever, he could correctly predict. And he had actually one small Sanskrit slogan called Ashadasya Pradama Divase, that it used to come. So he could predict how far or how fast a cloud will travel and reach a place called Rampur. So he could predict. I would say Kalidas may be the first forecaster or the first meteorologist who could correctly predict the monsoons. Now, when I come to monsoons, I don't know how many of you actually had actually gone and traveled, and what role does the ocean play. So if you had actually gone to a beach, I don't know, Goa luckily has actually, where I'm staying, has actually lots and lots of beaches. Most of the coastal states have actually beaches. So every day if you go and sit actually in a beach, especially in the afternoon, what happens actually, the land, especially the land part gets heated up, and we have a small low pressure system forming. At the same time, the ocean is actually relatively, we have sea surface temperatures which are actually cool. So we have a high pressure system over the sea or the surrounding area, and we have a low pressure system which actually forms actually over the land. So the winds actually flows from ocean to the land. It's what we call a phenomena called sea breeze. In the night, just the opposite thing happens. That's what we call actually a land breeze. So I just wanted to remind you, the whole thing actually of the land and sea breeze system forms within a day. The same thing happens on a seasonal scale is what we call monsoons. I'll come to that a little bit later. You can just note down my email ID, kramesh@nao.org. So you can always put questions at a later stage also. Now, what role does the oceans play on weather and climate? The ocean, let's say, of the Earth's surface. Okay. In addition to that, the top regions of the ocean, especially the tropical regions and the subtropical regions, hold the entire as in the atmosphere. I won't go into the details of the atmosphere because that itself is a huge topic. But I wanted to stress that the ocean is a very important role in trapping the heat from the sun and then storing and slowly releasing it at various stages. In addition to that, one of the major problems faced by the people say, "Why can't predict correctly?" It's actually various places all over India, plus Indian in Pune. So one of the major problems faced by the people is actually we have hardly any data over the oceans. So this slide very clearly shows that hardly any data from 1950. In recent years, we start getting the figures for India, not Indonesia, India. Only in the recent years, 2000 onwards, you can see the total coverage has actually substantially increased. Now, as I was mentioning, the period May to October, the entire region
Sir, your voice is breaking.
Saudi Arabia, Afghanistan, Pakistan, and all these get a low pressure system. And around 30 degrees off, there's a region called Saccharine high. We have a high pressure system over the about 30 degrees. We have a low pressure system over the land, especially Saudi Arabia, Afghanistan, Pakistan, all these areas. So winds will flow. According to physics, winds will flow from the 30 degrees south of the southern hemisphere into the northern hemisphere. But once they cross the equator, thanks to an effect called what we call a Coriolis force, it shifts or changes into the right-hand direction in the northern hemisphere. This is, I would say, is actually a simple form of actually land and sea breeze phenomena on a seasonal scale. That is why I mentioned to you what happens during a daytime, and this happens on a seasonal scale in the period May to October. Okay. Now, this again can be explained in another fashion. If you look at the global phenomena, you can see when the temperatures are more than 28 degrees centigrade is what we call a warm pool. This warm pool has actually tremendous repercussions, especially from the atmosphere point of view. Just look at this figure where you can see the area which is within the 28 degree. That's actually a red curve I have shown or a contour I have shown. You can see lots of area in the southern part of the equator in the month of January is actually warmed up. If you look at the month of July, the entire warm pool has actually shifted to the northern part of the equator. Just see the earlier one, which is actually the southern part of the equator. In the month of July, the entire portion has actually shifted to the northern part of the equator. This plays a very important role actually in our monsoon. And if you look at the map of India, I think most of you might have seen, this is actually very, very important in your 9th or 10th standard. If you look at actually some Oxford Atlas or maybe whatever atlas you have taken, you can see this is the distribution of rainfall during the monsoon season. Now, why monsoon is important? I would say now we are actually now in the monsoon season. From the period June to September, this 4 months, monsoon gives actually drinking water, agriculture, hydroelectric power, anything you name, it is purely because of the monsoon season. And 75% of our mean annual rainfall comes during these 4 periods. So I would repeat again, these 4 months, June, July, August, September, there is a summer monsoon season, gives about 75% of our mean annual rainfall of about 36 meteorological subdivisions which are spread all over India. Another interesting phenomena which I wanted to show you is actually if you look at the northwestern parts of India, like say Rajasthan or Gujarat, etc., they receive only 10 centimeters of rainfall actually during the monsoon season. In fact, 1 day's rainfall in Rajasthan can be actually the monthly rainfall or the seasonal rainfall or even the annual rainfall also. And if you go along the same latitude belt, there are things like say, I don't know, if you are actually visit a place called Meghalaya state, Megha means actually clouds and Alaya means actually abode. The name itself is actually abode of clouds. And there are places like say Cherrapunji and Monsoon Ram, which receives about 1,000 centimeters of rainfall in 1 day. See, if you see in one place we have only 10 centimeters of rainfall, in the same latitude belt if you go in the northeastern area, like say Meghalaya, we get 1,000 centimeters of rainfall. So why there should be a disparity? Why we have only 10 centimeters in Rajasthan and 1,000 centimeters in, let's say, Meghalaya? This is basically because we have a thing called topography, or let's say the mountainous terrain. To explain that, I'll come down further. If you go along the west coast of India, starting from Kerala up to Mumbai, we have a thing what we call Sahyadris or Western Ghats. So most of the rainfall for the west coast of India is actually on the windward side of the Sahyadris. So you can see most of the rainfall. Mumbai, if you are living in Mumbai, you get lots and lots of rainfall in Mumbai. If you are living in Panjim, you get a lot of rainfall. Around the coast. But if you go to like Pune, for example, Pune hardly gets not Pune are very, but Pune is on the leeward side. It's actually the Sahyadris is on, and most of the regions are areas are on the windward side of the mountains, like Trivandrum, Cochin, Mangalore, Karwar, all these areas around the windward side. So all this best you can see, we get lots and lots of rainfall. No doubt, even in Rajasthan also there are mountainous terrains like say Aravalli Hills, but its orientation is different. So the orientation of the Western Ghats or Sahyadri is actually in the north-south direction. So this is something which you should keep in mind. Now I will just show a small cartoon just to show you. I don't know how many of you heard about weather and climate. Most of the people are familiar with weather. It's actually the condition of the atmosphere at a particular place and the location. And climate is the region of the location of the atmosphere for a longer period of time. So I'll just show a small cartoon which will very clearly explain this.
Here we go. Could it be a nicer day for a hike? I don't know what you're bringing all that stuff for. Hey, you never know when the weather's gonna change. Gotta be prepared. RJ, it's like the sunniest day so far this summer. No way it's gonna rain. Right now it's sunny, but I'm telling you, weather is the condition of the outside air or atmosphere at a particular time and place. It can change quickly. Ever hear of braving the elements? I think so. Well, it means the elements of weather. Air temperature, air pressure, humidity, wind, clouds and fog, and precipitation like rain, snow, and hail. Those are all elements of weather. RJ, I really don't think the weather's gonna change right now. Oh yeah? I'm willing to bet you that 2 elements of weather are about to change as we hike up this hill. I'll take that bet. What's gonna change in 5 minutes? How about temperature and air pressure? Even though it's sunny, the temperature of the air can still change. As we hike up the hill, it's going to get cooler because we'll be at a higher altitude or elevation. The higher we go, the cooler the air is and the higher the air pressure. How much cooler can it get? Well, this hill isn't very high, so it won't get much colder. But if we were hiking something like Mount Everest, we'd be talking about seriously freezing temperatures. Whoa. So the higher we climb, the colder the air temperature? Yep. And as we climb, it's going to get windier too. Cool air is heavier than warm air, and it sinks. As it sinks, it gets warmer. Warm air rises back up again. When air sinks and rises like that, it causes winds. The higher we hike, the cooler and heavier the air is, and the faster it sinks. And the faster air sinks, the faster the wind blows? You got it. So it gets a little cold and my hair gets messed up. I can handle it. Okay, then what if it rains? Rain? The climate is very nice today. Sam, climate has to do with the usual kind of weather in a certain place over time, not on a particular day. Check it out. There are different climate zones all over the world. The main differences between each climate zone are precipitation and temperature, and those two things make the plant and animal life of each climate different. Climate is the overall weather pattern of those two elements in a certain area over time. So weather changes day to day. Perfect. It is a warm, sunny day, but this heat means more moisture is being evaporated into the warm air. As that warm air rises higher, it cools, and that moisture turns back into droplets of water. When that happens, clouds form. But clouds can't hurt us. They're big, fluffy puffs of air. They're big, fluffy puffs of cold air, ready to burst with rain. You seem to know a lot about the weather today, RJ. Did you watch the weather on the news or something? I always check the weather. That weather guy is called a meteorologist, and his job is really important. Meteorologists study weather patterns to try to predict future weather. Who needs a meteorologist when I have you? I think I felt a drop. Did not. Come on. You have to be kidding me. What'd I tell you? You told me, all right. Weather describes the condition of the outside air of a place at a certain time. And at this certain time, it's raining. But like you said, many factors affect changes in weather. Weather changes every day, and climate describes the weather of a place over time. Climate zones explain weather patterns and plant and animal life of particular areas. And I think we should move to a climate where it never rains. Oh, come on. A little rain never hurt anybody. Lucky for you, I brought an extra raincoat. Thanks. I guess we can still hike thanks to all your rain gear. But how am I supposed to paint? Watercolor?
So that was actually a small clip on, I would say, on weather and climate. Now let me come down to the subject proper. So each monsoon is actually unique, I would like to say. And each monsoon is unique in three important aspects. One is the monsoon onset, which takes place over Kerala. And then there are conditions, what we call an active and break in monsoon conditions. And plus in addition, as I said, there are 36 meteorological subdivisions. Some of them will actually receive lots of rainfall. So that's what we call a quantum of monsoon rainfall. So if you look at the picture, on the first picture, you can see it hits Kerala coast almost on the 1st of June every year. And then slowly covers India Indian subcontinent by 45 days. That is, it covers or reaches India Indian subcontinent by 15th of July. And some of the statistics is actually shown. The earliest onset date was actually on 11th of May, and the most delayed was actually 18th of June. I won't go into those details. There are several things which people have been doing. But if you look at, it is not same every year. For example, if you remember, about 7 years back, that is in 2013, the monsoon covered the entire Indian subcontinent in 16 days, 1/6. Even though it is supposed to cover in 45 days, it covered the entire Indian subcontinent in 16 days. This is actually very, very, let us say, I don't know. Remember, this was the year when we had actually Uttarakhand floods and Kedarnath was fully flooded. So we had Uttarakhand floods in 2013 and the Kedarnath temple and all these things are almost submerged. So this year it took only 16 days. In fact, it reached almost 1 month in advance. That is, instead of reaching by 15th of July, it covered the entire Indian subcontinent by 16th of June. And there was another year, that is the year 2002, which was actually a drought year or a deficit year. It took 76 days. Instead of 45 days, it took 76 days to cover the entire Indian subcontinent. That means it reached only by 15th of August in the year 2002. So this was actually a drought year. So I just wanted to say there is so much variability within the monsoon. So 2013 was different, 2002 was different. Now what happened this particular year? This particular year was actually almost well in advance. It reached actually and covered the entire Indian subcontinent 26th of June, which is very, very good. And this year we had a reasonable amount of rainfall over the entire Indian subcontinent. I won't go into that. But if you look at the map of India, as I said from the beginning, from 1st June to 30th of September, there are 122 days. Some days it rains very, very heavily. Such a condition is what they call an active monsoon condition. But there are several days when there is no rainfall, like the picture I have shown here, except Tamil Nadu region and the foothills of Himalayas. You hardly get in a rainfall over the entire subcontinent. Such a situation is what we call a break-in monsoon condition. A break-in monsoon condition is dangerous for the hydroelectric power. It is dangerous for the drinking water. It is dangerous for the agriculture, especially if there is a prolonged break. Such things are actually dangerous. So both are equally dangerous. I won't go into the details. Now, what role does the oceans play? So during an active monsoon conditions, what we call is actually we have systems, convective systems, which actually form in the Bay of Bengal. And they suck moisture into peninsular India and you get lots and lots of rainfall over the Indian subcontinent. Such a condition is what we call an active monsoon condition. The arrows which are shown is what we call winds at about 1.5 kilometer above the mean sea level. And the colors which are shown is what we call outgoing long radiation or OLR. I won't go into that details unless somebody is interested. It's a purely meteorological thing. Now, another interesting thing which happens actually, some days, I don't know, if you remember, in your own lifetime, for example, in the year 27th of July 2005, almost 1 meter of rainfall fell in one day in a place called Santa Cruz in Mumbai. Santa Cruz is the area where we had our airport or very close to that. And about 15 to 20 kilometers away, there's another place called Colaba. So remember, the rainfall over any region is highly, let us say, discrete. Within 15-20 kilometers, there is so much of variability. One place we have 1 meter of rainfall, About 15 to 20 kilometers away, we have only 7 centimeters of rainfall. This is what it makes it very, very difficult to predict. And such an event, if the rainfall or the daily rainfall is more than 10 centimeters in a day, is what we call an intense rainfall event. I won't go into that much details, but there was a study done by Professor B.N. Goswami and other people, especially in India. Their study clearly showed that the low and the moderate events are actually showing a decreasing trend, whereas the heavy rainfall events, that is rainfall more than 10 centimeters in a day, and very heavy rainfall events, especially which are more than 15 centimeters in a day, both are showing an increasing trend. This is actually a very, very dangerous thing. I will explain in a very simple fashion. Every day we take our, let's say, our breakfast, then sometimes we take something in the 11 o'clock, sometimes we have a lunch at 1 o'clock or 2 o'clock, then we have an evening tea, and then we have a dinner. Imagining if you don't take such things for a long period of time, say at least 7 days or maybe 1 month or whatever, and all these things, if it falls on one particular day. So this is actually a very dangerous thing. That's exactly what happens during an intense rainfall event. Several days there is hardly any rainfall, but in 1 or 2 days, what should have fallen in 1 week or 10 days or monthly rainfall falls in one particular day. So we'll have actually 3 or 4 such intense rainfall events of about 1 meter or 60, 70 centimeters, which makes the total remain same, but in between we hardly have any rainfall. This is bad for agriculture, this is bad for drinking water, this is bad for hydroelectric power. So the rest of the water will just flow actually into the Arabian Sea. In addition to that, another interesting phenomenon, as I said, is actually the amount of rainfall. The amount of rainfall is actually highly variable. This is actually a picture again taken from the Indian Institute of Tropical Meteorology. You can see from 1870 till now, that is the year 2000, you can see there is so much of variability. Some of the variability is associated actually with a phenomena called El Nino. In fact, the monsoon over India is not purely driven what happens only in the Arabian Sea or in the Bay of Bengal or in the Indian Ocean. Monsoon is actually a global phenomenon. So what happens in the Pacific Ocean, what happens in the Atlantic Ocean, what happens in the Antarctic Ocean or maybe the Arctic Ocean, everything is actually affecting our monsoon, including the Indian Ocean. So this is just a phenomenon just to show you how the monsoon variability is there. Another interesting thing which we can see in this picture is actually, if you look at this picture, there are an epoch of actually wet, dry, wet, dry. You can see from 1870 to 1900, we have a 30 year of actually epoch of wet conditions. Most of the rainfall was actually normal or excess. Whereas from 1900 to 1930, we had actually an epoch of actually lot of deficit or drought conditions. Again, we had actually wet. And 1960 to 1990, again, we had dry conditions. And everybody thought from 1990 to 2020, we'll have actually a wet. If you look at the previous picture, but the conditions were not the same. Again, we had actually dry. Mind you, I'm not blaming it to climate change or whatever. So another interesting phenomena, what happens over the Indian Ocean is what they call cyclones. And usually they form in 2 seasons. What is prior to the monsoon and one is after the monsoon. I won't go into those details later, but if you are interested, you can always send an email to me. One question which people are really worried is actually, is the climate change? Is it going to increase the frequency of cyclones or their intensity, or will they form in, let us say, other seasons also there? And cyclones are called by different names. See, for example, in the Pacific Ocean, they are called typhoons. In the Atlantic Ocean, they are hurricanes. Only in the Indian Ocean, they are called actually cyclones. So you can see, they are called cyclones in the Indian Ocean, typhoons in the Pacific Ocean, and hurricanes actually in the Atlantic Ocean. Even in the Indian Ocean, if you look at majority of the cyclones form in the Bay of Bengal, and in the Pacific Ocean, most of them form in the Northwest Pacific region. You can see the Southern Atlantic is actually hardly there are any cyclones. Same is the case with Southwest Pacific. I won't go into those details. Now, one worry is actually, will they increase? Or the extreme events, will there be more and more of cyclones? Or so can we predict well in advance? These are some of the things which we have done. One of my colleagues, Dr. Unni Krishnan, along with me, we had actually done, if there is a greenhouse gases like say carbon dioxide, it's increasing, what will happen in future? So we actually did a study and we predicted some of the things. I will show that. And another thing which we did was actually, with their intensity increase. So this picture, the bottom picture shows actually what was actually the current scenario. In the current scenario, you can see most of the cyclones going and hitting actually the northern parts of Andhra Pradesh and Orissa coast. In future also, the top picture, that the figure number B shows, majority of the future cyclones are unfortunately going to hit the same Orissa coast. This is actually in the year, this is actually 2050, or this one can see, when there's actually doubling of greenhouse. The bottom is actually what we call a control run. The control run, you can see, most of the they are going to the same Orissa coast. And these are some other things. Say, for example, if you remember last year, year of cyclones. We had about 8 cyclones, and 5 of them found actually in the Arabian Sea. In fact, it has never happened in such this one. And if you look at the damage it has caused, so much of damage it has caused into I wouldn't go into the details. You can see, let's say Thailand, Myanmar, Sumatra, Maldives, Western India, you can see it. And last year in 2 cyclones almost occurring simultaneously. That's both of them simultaneously happening. That's actually a Khyar 24 to 1st November and
Sir, I suppose there is a discontinuity in the network.
occurrences. Now, what will happen in future? This was a study done by one of my students. See, Gobika, he is actually working currently at the National Institute of Oceanography. People want to know what will happen in future. So we wanted to predict what will happen in future. In future, this is going to happen. If you look at the figure, which very clearly shows in future, the Western Equatorial Ocean and Arabian Sea is going to warm substantially. This is for the year up to 2100. This is actually showing a very, very dangerous trend. If some of the cyclogenesis parameters is what we call sea surface temperature, all these things, if it is showing an increasing trend, we'll have more and more such cyclones over the Arabian Sea. Now, let me come to my third topic, what we call a climate change, which most of you will be interested. So, a lot of people are worried. Is there a climate change? What is a climate change? Whether the climate has really changed? Is there a reason? Can we stop it? Will the climate change in future also? What are its impacts? All the impacts of climate change are not bad. There can be a positive impact, there can be a negative impact. One of the most important things actually, how can we adapt ourselves to a changing climate change? So as I showed actually the cartoon which you might have seen, climate change is a long-term change in the average climate of the planet or a region. Now, if you look at most of the meteorologists, as I mentioned, what is a meteorologist? I myself is a meteorologist. Most of the meteorologists believe that it's actually basically because of us. 99 out of the 100 climate experts is actually humans are the main causative factor for this climate change. It's basically because of the fossil fuel, the factors on the coal, the natural gas, and the oil, especially which you have seen on those details. And I don't know how many of you might have heard about a phenomenon what we call a greenhouse effect. In fact, the sun is a major driver for most of our weather phenomena, whether it's the monsoons or cyclones or the rains or whatever. And I don't know how many of you might have heard about atmosphere. Atmosphere, there are different layers. I won't go into that details. We have a troposphere, we have a stratosphere, we have a mesosphere. We won't go into that. But it is actually the sun which actually sends its radiation into the earth, and that is what keeps it actually warm. If there was no sun, this one would have been a very, very cold and desolate or isolated place. Now, what are the various main greenhouse gases? Most of us might have heard about carbon dioxide, but methane is also an important greenhouse gas, nitrous oxide, CFCs, HCFCs. The problem with most of the things actually, they stay in the atmosphere. That's a very, very dangerous thing. Look at the fifth column in the this one you can see. Methane stays about 12.2. Nitrous oxide stays in the atmosphere 120 years. Please remember this, 120 years. and CFC stay for 102 years, HCFC for and perfluoromethane stayed 50,000 years. Imagine. This is actually very dangerous. See, some of the things which they say is actually this one, and the last column very clearly shows its global warming potential. Now, why we should bother? Say, for example, is it really concerning me? Why should I bother the greenhouse gas? But basically, the greenhouse gas is needed. If there is no greenhouse gases, the earth will not have been warmer. But excess, increasing amounts of actually the man-made greenhouse gases is actually changing the significant weather patterns. Now, I'll show this very clearly phenomena. It very clearly shows if there's a particulate matter in the atmosphere, it stays hardly for 1 week. But the greenhouse gases, it stays in the atmosphere more than 100 years. Please remember, 100 years is a very long time. I don't know whether in our own lifetime we'll stay for 100 years, but this will stay in the atmosphere for a very long time, and that can change the whole atmospheric phenomena. And this greenhouse gas is actually a warming effect on the land, on the greenery, on the ice, and so many things. Okay, so this is something which we have to remember. So the emissions which we produce today, the composition of the atmosphere will be totally changed. It will change the few centuries, especially for our coming generations to change. Now, if you look at from the measurement point of view, if you look at from the first 100 years, 1901 to 2000, the temperatures have substantially increased. But if you look at the recent, this one, for example, 1910 to 1945, it has slowly increased. But the last slide you see, from 1970 to 2000, you can see the entire northern hemisphere, the temperatures substantially increased, and the trends have shown a very, very high. This earlier figure, this figure actually shows the spatial trend of actually how the temperatures have increased, and this slide shows how the temperatures has increased on an, let's say, temporal scale from year to year. So in the last 100 years, you can see how the temperatures have increased, how it has increased in the 50 years, but the temperature rise has been substantial. In fact, 2018 was supposed to be the warmest year. Now I would say 2019 is one of the warmest years, which is actually dangerous. Every year it is keeping on increasing and increasing. That has tremendous repercussions on that. Now, what will happen in future? By, let's say, atmospheric models, we can very clearly show that the temperatures will rise by about 6 to 8 degrees Celsius in most parts of the northern hemisphere, like say Arctic and other regions, as well as in the ocean also it substantially increases. Now, in the Arctic Ocean, if you look at way back in 1988, the temperatures were actually, there was a lot of what we call sea ice. In fact, there is a substantial difference between Arctic and Antarctica. Don't think it's not only in the spelling, or one is a North Pole and the other is a South Pole. Arctic, there's an ocean. Antarctica, we have a continent. So they put a lot of things differently in from the physics point of view and from the circulation point of view. I won't go into that. But if you look at this figure, you can see substantial, let's say, decreasing of the sea ice, which was floating on the Arctic Ocean. From 88 to 1990, that has substantially increased. 2001, by 2005, there is hardly any sea ice over the ocean. This is dangerous for, let's say, habitat like our polar bear. And how can we prevent it? There was actually a study done by some of our scientists. We had actually from National Institute of Oceanography, one of our scientists from NIO, we had actually a thing, just like we seed the clouds, we had actually seeding actually of the ocean. It's called what we call LOHA effects. It's called where we wanted to do an experiment over the ocean. So this was a German vessel called Polar Stern, where we put a lot of, let's say, pellets, iron pellets over the ocean. And LOHA is actually nothing but Hindi in iron for this one. And FX is actually a fertilization experiment. So we wanted to seed the ocean and put things over the ocean and see how the things, and we chose an area of 300 square kilometers to do that. And this was actually done. But just like over the atmosphere where we are doing the cloud seeding or the ocean, neither the atmosphere nor the ocean stands still. They will keep on changing. There was sort of hue and gray. So that experiment had to be dropped. So these are some of the photographs which are taken during that, and how the primary productivity has increased. So I'll just go to a small quiz. So I would like you to do, just, I don't want you to give the answer now, but please remember, this is like an assignment for you. Just see the most widely discussed impact of climate change. You can just write down the answer and maybe give it to Manoj sir or maybe Mahajanji. or this one, or maybe this one. So you can see the most widely discussed impact of climate change. Is it the sea level rise or deforestation or soil erosion or none of the above? And the climate change will have an impact on what? Will it have an impact on agriculture, natural ecosystems, your water resources, air quality, oceans, coastal zones, energy and human health? All of the above. That's the last answer. Which sector is the largest emitter of actually greenhouse gases in India? Whether it's a transport, domestic, agriculture, or electric power generation? And which of the following is not actually a greenhouse gas? Is it water vapor is not a greenhouse gas, or methane is not a greenhouse gas, or carbon dioxide is not a greenhouse gas, or nitrogen? Which one of the following is not, or rest are actually greenhouse gases? CFCs are greenhouse gas that have caused a rise in 0.3 degrees centigrade. Name the CFC which is actually used in your refrigerators, which most of us do use. Is it freon, methane, carbon dioxide, or ammonia? And September 16, the couple of days later, we will have actually the Ozone Day. The World Ozone Day is celebrated every year on 16th of September every year. So in fact, this was actually, let's say, discovered. Was it in 1960, 1980, or 1985? So this discovery has actually led, or the discovery of ozone hole has actually led for 5 scientists to get actually a Nobel Prize. Okay. So you can just identify which year. And most of the ozone is actually found over Antarctica. I won't go into that. And if all the ice over the Antarctica starts melting, how much will the sea level rise? There is a question, whether it's 10 to 15 meters, or 20 to 30 meters, or 40 to 45 meters, or maybe 60 to 65 meters. And another question which people always worry is actually, what do you mean by greenhouse effect? Is the legislation passed by the US Congress, or you change the house green to become an environmentalist, or the gas in the atmosphere which trap the heat and block it from escaping into the planet, or if you build a greenhouse? And why it should be important for us to know about the southwest monsoon? One of the most important things I would say is actually 50% of a food grain is actually produced during this period, June to September. That's what we call a kharif crop. Okay. And in addition to that, 60% of the oil seed. In fact, monsoon, we can properly say, is actually one of the most important things, much more than the, let's say, the finance minister. Always we say it's actually a gamble of monsoons. The monsoon is bad. None of things can be good. But nowadays we have shifted actually from agriculture to, let's say, service sector, etc. And the rabi crop is actually from the period October to April. But the main important thing is actually this kharif crop is very, very important, for which most of the regions are actually like rainfed. Now, what will happen to the agriculture? There is actually a decrease. There is actually 2% rise in the mean air temperature. The rice yields will substantially decrease, and it will be this one. And in addition, if there is actually a drought or deficit, the area will substantially decrease, and most of the farmers still practice the good old rain-fed system. And not only that, the farm level, this one can actually substantially reduce. So I would stop here, and I can take a couple of questions if you like. I don't know how much time I have, Manojji.
5 minutes we have, sir. 5 minutes we have.
Okay, fine. Thank you. So I can show a small cartoon actually on clouds.
Yes, sir.
These are the different types of clouds we actually see in the atmosphere.
Clouds can often be a great visual indicator of certain weather patterns, and they can even act as a harbinger of upcoming weather conditions. In this brief weather tutorial, we will discuss 4 primary types of clouds, as well as some combinations of hybrids within these categories. We'll show some specific examples of each, and we'll also look at some of the weather elements associated with these different cloud types. Clouds are categorized by their structural characteristics and the height in the atmosphere at which they develop. The 4 main forms of clouds that we'll talk about are cirriform, cumuliform, stratoform, and nebuliform. There can be different combinations or hybrids of each of these cloud types. Cirrus clouds are high-level clouds that typically form between 16,000 and about 50,000 feet above the Earth's surface. And the Latin word cirro means curl of hair. And many times cirrus clouds have hair due to the thin, wispy structure that they exhibit. Cirro can also be a prefix to describe high-level clouds.
There is a break in voice.
Tiny ice crystals in the upper parts of the troposphere, which is the layer of the atmosphere where all weather occurs. And cirrus clouds are often thought of as indirect indicators of weather patterns. Sometimes they may accompany a strong jet stream in the upper atmosphere. And cirrus clouds can also be seen preceding surface fronts by more than a day or two. Cumulus clouds might be one of the more recognizable cloud types. Cumulo is Latin for heap or pile, and cumulus clouds can often look detached or isolated from other clouds, and they'll often appear as fluffy white cotton balls or perhaps in cauliflower. These clouds are considered low clouds, usually forming between a few hundred to 1,000 people above the Earth.
So there is a break.
Okay. So let us see the picture only. Picture only now.
Okay.
Conditions within the southwest. Layer clouds often appear as a sheet or layer of cloud that exhibits a little definition or features. In other words, they will typically appear as a hazy white or gray mass. Stratus clouds are primarily thought of as low clouds, but they can also be observed in the middle to upper parts of the atmosphere as well. Mid-level stratus clouds are referred to as alto stratus, and high-level stratus clouds are commonly identified as cirrostratus. Nimboform clouds are also representative of a hybrid combination of different categories. Nimbo is Latin for rain. The two common nimboform cloud types are nimbostratus and cumulonimbus. As you can probably guess, nimbostratus are layered clouds producing rain or precipitation. These clouds can extend out the middle to upper parts of the troposphere, but they are typically only seen in the lower parts since they will usually obscure any clouds above. Cumulonimbus are also a unique type of cloud that extends from the lower to the upper parts of the troposphere, and otherwise known as clouds. We briefly mentioned cirrostratus, but another high-level cloud is cirrocumulus. These are similar to altocumulus, the difference being that altocumulus form in the mid-levels of the troposphere, while cirrocumulus clouds are in the highest part of the troposphere. Altocumulus clouds have some variations of their own. One such variation that frequents New Mexico is the altocumulus standing lenticular, sometimes simply referred to as lenticular, haze, or even wave clouds. These clouds are common on the leeward side of topographical barriers, such as mountains, where a thin layer of air is above the crest or peaks. Stratocumulus clouds are another combination of two previously mentioned categories, stratus and cumulus. So we've discussed several types of clouds. We hope that you've learned something about clouds, and maybe you can scan the skies next time you step outside and identify some cloud types on your own. For more information, refer to the National Weather Center.
I think that was all. So maybe if there are questions, I'm ready to take that.
Yes, sir. I have a few questions here.
Yeah.
There is a question from Mr. Shubhankar Chatterjee.
Okay.
He asks, is there any correlation between air pollution and thunderstorm? As the air pollution increases, is it possibility that thunderstorms will increase?
Okay. Yeah, it's a very good question. That's why I actually showed the image for the thunderstorm to form. What you need is actually highly vertically developing cloud. So if there is an air pollutant, it will actually form a cloud condensation nuclei. Just a sheer cloud condensation nuclei cannot give rise to a thunderstorm cloud. For a thunderstorm cloud to form, we need some clouds which are about 15 to 16 kilometers in height, which is actually very, very difficult to form. No doubt, it can actually become, let us say, a cloud condensation nuclei. Unless there is a strong vertical movement or this convection is there, you won't get. In fact, if you are coming from Calcutta region, all those regions, they are what we call a Kala Baishagis. Kal Baishagis they call. They basically form because of the huge vertical development is again formed because of the strong convection. No doubt, this, let's say, the pollutants can actually add as actually, let's say, matter which it can form, and this one. But that cannot be the only reason. We need actually strong condensation, let's say convection. Then only we can have a huge cumulonimbus cloud. We need for the thunderstorm to form, we need a huge vertically developing cloud. Okay, next question. Manoj,
Sir, Miss Farhad Banu, she asks about the weight of cloud.
Oh, to be frank, I'll put it this way. For example, I don't know whether she has actually traveled by a flight or whatever. Recently, I'll put it this way also. Recently, we had actually at the Indian Institute of Tropical Meteorology, we recently started going through the clouds. Okay, I don't know how you can say weight of a cloud or whatever can be measured, but basically people have been trying. I'll put it this way: can we seed a cloud? Just now, as the previous questioner was asking, can we have a pollutant like? So there are two different types of things which we use. One is actually what I call actually a sodium chloride or silver iodide. These are basically try to feed, let's say, seed a cloud. But then the problem, as she was asking, the weight of the cloud. The cloud, as I was showing the nice movie, or let's say the nice, this one, which has it changes its shape and size. And you cannot tie down a cloud to the ground. So let's say the government of Maharashtra, government of Karnataka has invested huge amount of money in cloud seeding. But then what happens actually, there's a huge topic, what we call cloud physics. The time which it forms a cloud droplet, a rain droplet, until it reaches the ground, it is a very, very difficult thing and process. So the Maharashtra government can invest a huge amount of money, or like the Karnataka government can invest a huge amount of money. But the cloud, once it forms and rains, it may either rainfall over the Andhra Pradesh or maybe Tamil Nadu region, or may even go into the Bay of Bengal region, or the rainfall may come actually to Goa state. But then the investors are actually like Maharashtra government or maybe Karnataka government. The main problem is actually the clouds are carried according to the wind at that level. And there are several conditions. The cloud should be of sufficient thickness, because if it's a small, thin, narrow cloud, it will not, because you need first of all to form a cloud droplet, and then you should be having a rain droplet. And the rain droplet, I don't know if you are watching actually, last few days in Goa, we had actually small drizzle type of things, rains. And then we had a huge rain droplet also. So the small drizzle type of things or rain, they just get carried away by the wind. You can also observe, maybe I don't know whether it's the Delhi or Mumbai or whichever region you are coming from. Just observe the rains, look at the clouds. It's so fascinating, look at the clouds. That's why I wanted to show that this one. And the rains also keeps on changing. Anyway, I have not measured the cloud anytime. Maybe in future I can ask some of the scientists from IITM to do that such an exercise. Not theoretically, you cannot go and measure it, but you can do some physics calculation and do that. Any other questions, sir?
Thank you, sir. So there is a question from Ms. Suchita Naik from Goa. There is increase in deforestation, but doesn't seem to have effect on monsoon, or how it is affecting monsoon.
Okay. That's a very interesting question. See, when we say deforestation, it's a very, very interesting thing. Basically, one of the main things what happens over if you remember, as I said in the beginning, 71% of Earth is actually oceans. And most of the moisture for our Indian Ocean comes actually from the southern part of Indian Ocean. Okay, it is not actually over what happens over Arabian Sea or the back. And ocean is a major driver. If you remember the first slide I had shown, the most of the moisture is actually from the southern Indian Ocean. It is carried from the southern Indian Ocean into the Arabian Sea and into the peninsular India, where we get lots and lots of moisture. So about 70 to 80% of the moisture for the monsoon rainfall comes from the ocean. No doubt, this one also what we call evapotranspiration also plays, which comes actually from the plant. No doubt it plays a very, very important role. But then the major driver for the, let's say the monsoon or let's say other phenomena is actually the ocean. No doubt this trees do play, but then I would say the other way around. Water falls actually over the land is substantially stored, especially if the water falls on the land. all these things actually, these trees or their roots have to retain, and we'll have actually more and more of groundwater recharging. If there is a more and more of deforestation, most of the groundwater which should have been there will be vanished, and everything will again go into the Arabian Sea and Bay of Bengal, which is bad from the agriculture point of view, from the drinking water point of view, and so many things. Any more questions, sir?
So it is affecting in the other way.
Yeah,
No,
exactly.
sir. There are
No.
yeah.
Yeah, deforestation does play an important role. Deforestation does play an important role, but the major driver I would say is actually the oceans. No doubt the evapotranspiration also plays, I agree, but it helps in retaining the water which is fallen over the land. Okay.
So thank you very much, sir. There are questions, but then we are running short of time, and then
I can take one more question, sir. If you want, I can take one more question. Or okay.
No, because it is almost
okay.
past 7. Yeah. So on the behalf of the
They can send the
participants,
questions to me. You can give my.
yes, sir. So on the behalf of the participants,
They can send an email to me.
Yes, sir. So certainly those who have questions, and of course the kind of session we had today with Dr. Ramesh Kumar, it certainly will create a curiosity in our minds about looking into the monsoons, about the clouds, and that is what is we need to pass on to the children, pass on to the student. How do we measure the rainfall? How the factors affecting, rather than teaching in a confined textbook. So that is what I suppose is the thing to understand from Dr. Ramesh Kumar. You have enriched us, enlightened us with such a wide information about the monsoon, how the climate change affects monsoon. So on the behalf of Shiksha Shilpi, all the participants, I thank you very much, and I'm pretty sure that you will always be the part of our Vigyan Bharati, and will always require you to be in different sessions further. And I would also like to invite you, whenever you will be in Goa, do visit National Institute of Oceanography for a number of reasons related to oceanography.
Yeah, I forgot to tell that. Please visit NIO and maybe IMD, most of the IMD, and Indian Institute of Tropical Meteorology in Pune. Please visit. Thank you, sir.
Yes, sir. Thank
Good
you.
idea.
So thank you, sir, and thank you all the participants. And we need to meet. I would request Ajay ji to I'll pass on
namaskar.
to
Yeah. Yes, thank you very much to all the speakers who have given very informative informative lectures to us, and also thought provoking for further upcoming events. Now I also Shiksha Shilpi also thanks to Mrs. Dola Bhattacharya, Dilip Waze, and Narayana Isti, who has given also the very good input to the various questions, queries related to the teachers or the other participants in the different groups. So I also name these three persons who have interacted very nicely in our various groups. So this is the second day session, and all the speakers have done very nicely. So I thank you very much for this speaker, and also the huge number of the participants who have attended this day 2 session. So I also thankful to them. Now, in the next week, we have the Saturday lectures. So we will meet on the next Saturday. So thank you very much to everyone, and please fill up the attendance form and submit it as early as possible, because we are having a short of time to close it now, or to restrict the access for the participant. So I once again appeal to all the teachers to submit their submit their attendance form or attendance in that particular form. Thank you once again to everyone. Thank you, Ramesh Kumar ji. Thank you, Manoj ji. Thank you, all our team members. Thank you, participants.